Question 1. Which configuration connects two BJTs to achieve a current gain approximately equal to the product of their individual gains? A Darlington pair connects the emitter of the first transistor to the base of the second, multiplying their current gains. Question 2. What is the relation between common emitter gain beta and common base gain alpha? The mathematical relationship between common emitter gain beta and common base gain alpha is beta equals alpha divided by 1 minus alpha. Question 3. What occurs when the collector base depletion region expands to physically touch the emitter base junction? Punch through, or reach through, occurs when high reverse bias voltage causes the collector depletion region to span the entire base, shorting to the emitter. Question 4. Which composite configuration uses complementary NPN and PNP transistors to act like a Darlington pair? The Cycli pair, also called a complementary Darlington, combines an NPN and a PNP transistor, requiring only a single diode drop to turn on. What physical quantity represents the total integrated dopant density within the narrow base region of a BJT? The Gummel number represents the total integrated dopant dose in the base. It is a critical factor determining the transistor's current gain. Question 6. In which operating region is the emitter base junction reverse biased and the collector base junction forward biased? By reverse biasing the emitter base and forward biasing the collector base, the BJT enters the reverse active region, acting as a highly inefficient
Question
amplifier.
7.
Why is the common emitter breakdown voltage with open base lower than with open emitter? With an open base, any tiny avalanche carrier multiplication at the collector base junction gets amplified by the emitter current gain, triggering early
Question
breakdown.
8.
How does reducing the physical thickness of a BJT's base layer affect high-frequency speed? Reducing the base width shortens the minority carrier transit time across the base, raising the high-frequency transition cutoff. Question 9. What base-to-emitter threshold voltage is typically required to turn on a standard silicon BJT? Just like a standard silicon diode, the base emitter junction requires about 0.7 volts of forward bias to initiate full conduction. Question 10. What parameter measures the frequency where a BJT's common emitter current gain drops to exactly 1? The transition frequency, or FT, marks the boundary where the common emitter current gain drops to unity, defining the baseline radio frequency speed ceiling.